All right, here is chapter 4, and let's see what they ask you to do. We didn't pray? All right, well, let's pray. Okie doke. All right, let's see what they want you to do. Number 1, they say identify each triangle by its angles and its sides. So the first triangle is ABD. All right, so it says classify by its angles and its sides. So you must have 2 answers for this, right? One by its angles, one by its sides. And you got to know these words. I don't list the words out for you. You have to have these things memorized. All right, so let's talk about the angles first in ABD. Here's ABD. So what you actually have 2 possibilities for this, don't you? ABD. Now, by its, let's do angles first. All right, so if we classify it by its angles, what do we call it? You could call it acute, yeah, because it's an acute triangle. Or, if you wanted to on this, what else could you call it? Equiangular, that's right, because you know it's equilateral, right? So if it's equilateral, it's got to be equiangular. So you could say equiangular as well. Either one of these. You don't have to have them both, all right? Just one or the other for the angles. But you also have to classify it by its sides. We already talked about it. What is it by its sides? You could say isosceles, right? Because what's isosceles? At least 2 of the sides are equal to each other, okay? 2 or more of the sides, 2 or 3. So you could say isosceles, right? Yeah, you could say isosceles, couldn't you? Yeah, because at least 2 of the sides are equal. Or, if you wanted to, you could also say what? Equilateral. Either one of those. Doesn't matter. You don't have to have them both. But you do have to have one of these classifying by its angles and one of these classifying it by its sides. Make sense? All right. Let's take a look at triangle ABC. Triangle ABC. So ABC, that's that big old triangle. Classified by its angles. What kind of a triangle? A lot of people miss this. I can't understand why you'd miss this. Yeah, look at ABC. It's got a big old right angle right there, doesn't it? Okay, so it's a right triangle. So I'll just put right. And then classified by its sides. Look at it. Boom. This has 1 mark, right? 1 tick mark. This has, I don't know. Yeah, and we don't know any of these, right? This bottom one is double this one, right? So it's not the same side. This one right here, I have no idea. So none of them are the same, right? Or at least we can't tell that none of them are the same. So we call it scalene. That's right. All right. And number 3, triangle BDC. Triangle BDC. So let's find BDC. Here's B, here's D, here's C. First of all, by its angle. What kind of a triangle is it by classifying by its angles? It's obtuse, right? It's a big old obtuse angle right there. And you know it is. You don't have to guess because, look, that's a right angle and there's a little bit more. So it has to be obtuse. Would you agree? Yes, Mr. Hamrick, I agree with you. All right, so that's an obtuse triangle. What about by its sides? It's isosceles because you got 1 tick mark here and you got 1 tick mark here. That means these 2 sides are equal to each other. Don't care about the 3rd side. I know at least 2 of the sides are equal, so it's isosceles. It'd be nice if you spelled isosceles correctly, wouldn't it?
Is that how you spell it?
It's how I spell it, yeah. Isos, I-S-O-S, isos, and then celes, C-E-L-E-S, isosceles. All right, let's move on. Number 4. Change to a different color. All right, look at this. It says triangle FGH, triangle FGH is equilateral. Equilateral. Which means what? All the what? All the sides are equal, okay? And you don't even have to draw this thing out, do you? I don't think so. They tell you what this side is, FG. They tell you GH is 3x minus 9, and they also tell you FH. So they tell you all 3 sides of this triangle, don't they? Well, they kind of do, right? In terms of x, they tell you. So what do we do to solve? And they ask you, what do they ask you to solve for? So find x and the what? The measure of each side. Okay, so you actually have 4 answers, don't you? That's right. You could go any two equal to each other. It's equilateral. All three of these are equal to each other. Man, I've had people, probably not so much in this class, but we had this question on a quiz in my CP class. And, I mean, I had people, like, setting all three of these things equal to each other and trying to solve for x with all three of them equal to each other. Well, you can't do that. You can only have two things equal to each other, okay? So it doesn't matter which two, because they're all equal, right? They're all the same. So it doesn't make any difference. Let's take the easiest ones. Let's take 2x minus 2 equals what? X plus 5. Yeah, that's probably the easiest one. Subtract x from both sides, add a 2 to both sides, x is 7. So that's one of your answers. But it also says find the value of each of the sides, correct? All right, so if x is 7, we can do this in our head. 7 plus 5 is 12. Now look, that's really all the math I have to do, because I know it's equilateral. Save yourself a few minutes, right? Maybe not a few minutes. It wouldn't take a few minutes to do this, but at least a few seconds. Save yourself a little bit of time, because if this is 12, without doing any math at all, what are the other two sides? They got to be 12, because it's a what? Equilateral triangle, right? That saves you a little bit of time. You don't have to plug that into everything. Just plug it into one of them, and the rest of them are going to be exactly the same. Now, if you wanted to double check just to make sure that was right, you could do that, couldn't you? 3 times 7 is 21, minus 9 is 12. That works. 2 times 7 is 14, minus 2 is 12. Yes, that works as well. All right, but you didn't have to do that. You could have just written them down. Make sense? Yes, Mr. Hammer. Makes sense. All right, good. Number 5. Triangle. Let's see. Don't mind me talking to myself. It's isosceles. Is isosceles. Word sounds cool, doesn't it? Isosceles. LM. Still talking to myself. All right, so LM is, they said it's isosceles, but just knowing it's isosceles didn't really tell you which sides were equal, did it? So they tell you, right, they tell you right here which sides are equal. They say these two sides, LM and LN, are equal to each other. And they give you some more information. They say that LM is equal to 3x minus 2. They say that LN is equal to 2x plus 1. They also tell you that MN is equal to 5x minus 2. Alright, that's plenty of information to get going on this. Now look, the other one, all three were equal to each other, so I could have picked any three and set them equal to each other. But this is isosceles, only two of them are equal to each other, so I can only set these two equal to each other. So I set them equal to each other and solve for x. Subtract 2x from both sides, add a 2 to both sides, so x is 3. That's part of my answer. That's 1/4 of my answer right there. Now I got to find all the other missing sides. I got to find LM, LN, and MN. So let's put it into LM. 3 times 3 is 9, minus 2 is what? 7. So that's 7. Oh, look, I can save myself a second, right? LN is the same exact thing, isn't it? So that has to be 7. Right? If you wanted to plug it in, you could. 2 times 3 is 6 plus 1 is 7. Yep, works. What about this one? You got to do the math, though, don't you? Yep, 5 times 3 is 15, minus 2 is 13. So MN is 13. And there it is, right there. Easy, right? Yeah, I think so. All right, well, let me draw the next picture. Okay, here's our picture, and it says to find angles 1, 2, and 3. This shouldn't be that difficult. Let's see. What do you think the easiest thing to find would be? Yes.
Well, if you find, like, the one next to one, not the two, but in the other triangle.
Tell you what, let's just find angle 1 first of all. We could do it one simple little step. What's that little step? Yeah. I would find angle 1. I could do that in one little step. That's right. You just add these two together. How do you know that? Because this is an exterior angle is equal to the sum of the remote interior angles. Do you remember that? Okay. That makes it a lot easier, don't you think? I mean, you could take these two away from 180, put it here, take that away from 180, but you're going to get the same thing as just adding those two together. Does that make sense? All right. So you just add them together, and I don't know, whatever that is. 58 plus 39, and that's a 7, that's an 8, that's a 9, 97, right? All right, so that's 97 degrees. Now, what about 2? Just take that away from what? 180. So minus 97, and that's a 3, and that's a 7, and that's a, what is it, 9? Or 8. Okay, yep.
Excuse
So that's
interruption,
83.
Please excuse
All right, so that right there is
girls
83
basketball and
degrees.
boys basketball at this time.
What about
Thank
this?
you.
What about angle 3 right here? Look, I got these two. So what do? That's it. Add them up. So what is 83 and 38? That's 1...
35.
No, just my question. 83 and 35. That's an 8. That's an 11. That's 118. Right. So it's 180 minus 118, and that would be 62. 62 degrees. So there you go. Simple little arithmetic, right? Everybody good? All right, let's move on. Alrighty, let me draw this first. All right, there's our picture for number 9 and 10, right? 9 and 10. Oh, yeah, simple. Just takes a second on the video. Just pops up. X and Y, I got to solve for X and Y. So let's see. By the way, this really, really is helpful when they tell you this stuff, because sometimes you can't tell which angle is equal to which angle and which side corresponds to which side when you just look at the picture, right? You're not really sure exactly what they did to it. So looking at this really helps you out. I mean, you got to live by this thing, right? This really is important right here. PQRS, PQRS. So why does that help you? Because that tells you what angles are equal to what, right? It tells you that angle A is equal to what? Angle P. Not just by looking at it, because some people might look at it and say, oh, that angle looks like it's that angle, or something like that. They're not really sure which one's equal. So you look up here, they call this the congruent statement, and then you can tell what are equal to each other. So A and P are equal to each other, so that's equal to each other. 2x plus 4 equals 100. And so minus 4, that's what? 96 divided by 2 is 48. Is that right?
Yep.
Okay, so x is 48. All right, let's solve for y. Now look at this. Now some people might say, oh, 3y, that is equal to this, right? But not necessarily, because look at it, DC. Come up here and look at DC or CD. What is CD equal to over here? RS. So that has to equal 12, right? So those are equal to each other. So the math is not hard. It's just knowing what to set equal, correct? Add of 3 is 15. Divide by 3, y is 5. That's it. Now we get to do the proofs. Yay. All right, not the prettiest picture here. Talk about a weird looking letter. That R is weird.
Oh,
That's
that's
a
an R. I thought it
R.
was a lowercase.
Making it worse. Okay, here we go. Let's mark the thing. Here we go. RS equals TS. V is the midpoint of RT. Oh my goodness, this is so easy. Watch. So V is the midpoint of RT. So what does that mean? It means that those two are congruent to each other. What's the reason? Why are these two congruent to each other? Definition of midpoint. Exactly right. Okay, what else do we have here? That's right. You got it. SV equals SV because it reflects a property. And then the triangles are congruent for what reason?
Side.
That's pretty much it, okay? I'm not going to write everything down just for the sake of time. Shh. Settle down. I know the proofs are exciting, but you gotta contain your excitement, okay? So anyway, so you write all the given. All right. The reason for this is because definition of a midpoint. SV equals SV because it reflects a property. You got all that stuff. Then you can say the triangles are congruent because of side. Everybody good?
Yeah.
All right. All right, let's take a look at this one. Boy, people watching YouTube just won't have any idea what we were just talking about. Really. All right. All right, here we go. Angle N is equal to angle L. So this and this are equal. Given, obviously, JK, just kidding, and MK is they're equal to each other. And that's all they tell you. And look right here. This is what we could figure out. Why are those two angles equal to each other? Vertical angles are equal. So why are the triangles congruent to each other? Angle, side. It's not angle, side, angle, is it? All right. Now, you could have done this. Watch. If you wanted to, it would be a waste of time, I think. But you could have done this. You could have said, if these two angles are equal to these two angles, then this is equal to this because of third angle theorem, third angle theorem. And then if you really wanted to go angle, side, angle, now you could do it, couldn't you? All right. So you could go angle, side, angle, but you have to show that this angle is equal to this one to be able to do that. But why bother, right? You've already got the triangles congruent by angle, side. I would just go ahead and just leave it like that. Everybody okay with that?
You know if it's like
All right.
angle, side, or side, angle?
Because it's angle, side, because the side originally, without these three, let's get rid of this stuff. Okay, because look, it was originally this, right? And I said angle, side. Why didn't I say angle, side, angle? What if you put angle, side, angle, I'd mark this wrong. Why would I mark it wrong? Because the side on this one right here, the side cannot be in between the two angles, right? It's got to be outside the two angles. So look, I've got two angles. We call it a non-included, right? We call it a non-included side. So if it's a non-included side, it's angle, side. If it's included, right? If it's this and this, then I could call it angle, side, angle, because now the side is in between the two equal angles. All right, I did, but I said it again. Oh, we got time. We got time. We'll do the next one. We're going to do 13. All right, here we go. Here's our little picture. Let's mark it up and see what we can do. A, B, and C, B. A, B, C, B. Angle A, angle A, angle C. Look, DB bisects angle ABC. Now watch this. Here's angle ABC, this big angle up here, right? And it says that DB or BD bisects it. So that means if you bisect an angle, you split the angle into two equal parts or two equal angles, correct? All right. And now, and that's because of definition of angle bisector, exactly right. So that's given, angle of definition, or angle of definition of angle bisector. That's why those two are equal to each other. Now the triangles are congruent because of what? Angle, side, angle. But that's not what they ask, though. They don't ask you to prove the triangle's congruent. They ask you to, right, they ask you to prove that AD and CD are equal to each other. So you must prove the triangle's congruent first, right? And then you can say that AD and CD are equal because of what? Corresponding parts of congruent triangles are congruent. All right? No? Well, I don't say it. I say because they're corresponding parts. I think that's the easier way to say it. They're corresponding parts. All right, that's all the proofs. Let's do another.
Can you do 18? Or at least tell me the answer for it.
We'll do it in a second. We've got some time. All right, here's our picture. And let's see what we can do here. First thing is angle CAD. Angle CAD. That's this little tiny one up here. All right? That one right there. CAD. So look what we have. This is 92. You got these two sides equal to each other. So what must be true about this angle right here and this angle right here? They have to equal each other. And I think it's important to understand that. So if these two are equal to each other and this is 92, look what I can do. I can go 180 minus 92, which is what? 88. Okay? But does that mean this is 88?
Nope.
No, they add up to 88, and they're both exactly the same, so we split it in half, so it's 44. So that's 44, and so that's what that angle is right there. So is that angle. Let's see what we have to do. ACD. How about that? Look, ACD. That's the next thing they ask, isn't it? All right, so if that's 44, that has to be 44 as well. So far, so good. What about angle ACB? ACB. Oh, that's easy. Look, that's right, because look, that forms a straight line, doesn't it? And so we go 180 minus 44. Or you could do something else. You could do an addition problem, couldn't you? Come on, think about it. You could do an addition problem. What would you add to get this?
44 and 92.
That's it, 44.92, because this is an exterior angle. This is a remote interior angles right here. So if you wanted to, you could have just added those two together, right? Whatever you would rather do. So anyway, what is that? That's 36, is that right? 1, forgot the 1, yep. So that's 136. And then ABC. ABC, that's this whole thing right here. Now look, you've got this big old obtuse triangle. These two angles right here are equal to each other. Do the same exact thing. 180 minus 136 is what? 44 divided by 2, which is 22. And there you go. Alright. Alright, now to the one everybody's been asking about, right? I'll just keep recording. Number 18. So watch this. 18, you should have been able to get 18. 19 is a little tougher, but 18 is pretty easy, right? Actually, let's change the color again. It's about right there. And I am recording this. So this is point F, And you don't know what that is, do you? Correct. You don't know what E is. But you do know. Oh, I messed up. Remember I said this should be another letter because I put E over here. I think I told you that the day of the test, though. 2A0. Alrighty. And this is equal to this. Now watch this. If this is 2A0, that means this is the origin, isn't it? This is 0, 0. So if I went over 2A to get to this, and I went up 0, and these two are equal to each other, right? And this is perpendicular because that's the x and a y axis, right? So it has to be perpendicular. What must it do? It must divide those two segments into equal segments. So this is the same distance, but we're going to the left, though, aren't we? So it's going to be a negative 2A, what? 0. That's it, okay? What about this up here?
It's 0B.
Well, it's 0 something, isn't it?
Yeah.
It's 0 whatever. And you could write whatever letter you want. Okay, it doesn't make any difference. Okay, I think I've been using B for the next one. You could have said A. You could have said 2A if you wanted to, right? So there's several different options. I mean, one person might have written something. Somebody else might have wrote, like 0B. Somebody else would have written 02B or 02A. As long as it's 0 something, because we have no idea how high it is in relationship to the other stuff, do we? All right, so 0 whatever. 0 whatever. All right, but put a letter in there to represent that. Make sense? So that's not so bad, is it? I take that as a agree with Mr. Hamrick. It's not so bad. All right, let's do this one. Now this one, you're going to have to draw this thing from scratch. And there's different ways that you could do that. Because like when you cook from scratch, you don't use stuff that's already been done for you. You do it from I don't know why. Scratch, I don't know. Who knows? It's just what people say. So we have to, look, we have to position and label the triangle that is an isosceles triangle. Oh, I'm sorry. It's not just an isosceles triangle. It's an isosceles what? Right. It's a weird H. Right triangle with legs A units long. All right. Now there is, just because you drew it one way, somebody else could have drawn it just a little bit differently, and that's perfectly fine. Let's go red on this one. Isosceles right triangles. So remember what the key to this thing was to try to keep, as much as possible, try to keep the sides along the x and y axis. Just makes things a little bit easier. So if it's an isosceles right triangle, we've already got a right angle in here, don't we? Right there at the origin. So let's do this. I'm trying to make it the same distance. All right, it's not bad. Let me scooch that down just a tad. Here we go. All right, so watch. Those two are the same. I'll make a triangle out of it. And let's label it. So we've drawn the triangle. It's isosceles, which means these two sides must be equal to each other, correct? So what is this ordered pair right there? That's 0, 0. So we're labeling it. This is what they ask you to do. Now look at this point right here. Now we don't know exactly how far we went over, but what could you use? We've been using A and B, right? So we could say this is A, and then how far up did we go? We went 0. Now you got to be careful. This is where some people went wrong on this. You can't just say, well, what's the first coordinate going to be, or the first part of the coordinate? It's going to be 0, right? Some people put B right here, but B indicates that it could be any length. It can't be any length because this is an isosceles triangle. It has to be the same length as this. So if we went over A units this far, how far are you going to have to go up? A, not 2A, the same amount, the same. If I went 2A, it would be twice as big as this, and it wouldn't be isosceles. Okay? Oh. Either way, you can't do that. So this has got to be A, and that's got to be A. That's the best way to do this. It really is. There's another way I guess you could do this, make the right angle up here, but that would be way too hard. You've already got your right angle right here, don't you? So just use it. That's the easiest way to do that. All right? I think I just gave that to everybody, didn't I? Number 20? I think I did. So I don't think that it's going to be on the test. So we're finished. We won't worry about 20. We're running out of time anyway. So, all right. So there you go. We did take a test on chapter 5, right?
Yeah.
Okay. All right. So we'll do chapter 5 tomorrow, and we'll be finished.
Worry about number 20.
Right. Don't worry about number 20 on that. All right.